Hi everybody, welcome to another video in Pre-Calculus, section 1.5, Graphing Techniques, Transformation. So once again, this is a review of what we learned in Cauchy algebra and trigonometry. So, first we have vertical and horizontal shapes. So, vertical or horizontal translation. So we're just moving the graph, we do not change the shape. So suppose k is a positive number and we have the graph of the function y equal f of x. Now, if we add a number to it, then we will move up k unit, with of course k is being positive. If we subtract the number, we will go down k units. Of course k is positive, and we do that so the shape of the graph will not change. We just move the graph up or down. So here we have an example. F of x, let's sketch the graph of square root of x plus 2. So first we have the basic graph, square root y equal to square root of x. That is the basic graph. Now everything will move up 2 units because we have the plus 2 here. That meaning we'll go up 2 units. So we up 2 units. So for this point, go up 2 units, this point go up 2 units, and then so forth and so on. We have the graph. Go up 2 units. If it's minus 2, it will go down 2 units. And once again, we start with the basic function of square root of x. And then all the points are moved 2 units down. And we have this graph. Right, just translate. Of course, the graphing part is easy. I mean, if we just want to see how the graph, what the graph will look like, we just put in the calculator and get the graph. But the focus here of the idea of how do we transform the graph. In this case, if we plus a number, if it's positive, it goes up. If it's negative, it goes down. Right. Now, horizontal shift. If we minus h, it will be shift to the right h unit. Once again, h is positive. So if we have the original function f of x, now we replace the x by x minus h. If it's minus h and h being positive, it will go to the right. If it is the plus h and h being positive, it will go to the left. Now, see how it works. First we have f of x equal to absolute values of x minus 2. So the basic function is the absolute values is a v, right? So those basic functions we studied on the previous section. Of course, we have the v and always go to the point 1, 1, and that's just a v. That is y equal to absolute value of x. And after that, instead of absolute value of x, what we have is the minus 2 and the minus 2 here, meaning that we put 2 units to the right. So we have this point move 2 units to the right, this point 2 units to the right. So we shift the the V 2 units to the right. And we have this. That 2 units to the right. Yeah. So that V. Right. Now if we have the plus 2, it will be 2 units to the left. I would just say left 2 units. So we have once again the absolute values. And then we move 2 units to the left. This point 2 units to the left. Yeah. So by the way, if you want to graph absolute values, or if we use absolute values, this is under math. Go to numerical. I think that is numerical. That is ABS, absolute values, X. Let's say plus 2. Yeah, so the absolute values function will go 2 units to the left. Right. Next, let's do a few examples. Now, let's graph this function and then find the domain and then the range. Alright, so f of x equal to x minus 3 squared plus 2. So first, of course, we have f of x is the basic function, so I will graph the function. So this is y equal to x squared. That is the basic function. That's what we start with. Now, we have two components to it. First, -3. -3 is that of x. So that means it will be 3 units to the right. So we say right 3 units. And there's a plus 2. Plus 2 at the end of the function. So that means it go up 2 units. And the question is, which one do we do first? Because we move right 3 units, then up 2 units. Which one do we do first? Well, this one, it doesn't matter, right? We know that a point, so any point on the graph, we go to the right 3 units and then up 2 units. So this point here, move there. So the vertex will go here. Now this point, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. So we're gonna have this graph. There's the graph. Of course, if we want to test, we want to check it. X minus 3 squared plus 2. That's what we have. Right, so we start with the basic graph and then we just do the transformation. Simple enough. Oh, by the way, the domain and range. So based on the graph of this, the domain will be all real numbers because the x value will extend the whole number line. So all real numbers. we're going to write negative infinity to infinity. Range, the range only from that point and up, so moving from 2, including the 2, to infinity. Right, so that's simple enough. Next, the graph of f of x is given, so we have the graph like this. Sketch the graph of y equal f of x plus 3 minus 2. So this is different. We have the plus 3 here replaced into x, meaning that if it's plus 3, it will be 3 units to the left. Right? So if it's minus, move to the right. If it's plus, to the left. 3 units. And then the minus 2 be 2 unit up. So up 2 units. I'm sorry. This is minus 2, right? So we'll go down 2 units. So once again, if it's just moving, if it's just translation, it doesn't matter which one do we do first. So 3 units to the left, and then 2 units down. Right? So just do pawn by pawn. 3 units to the left, 1, 2, 3, and then 2 units down, 1, 2. This pawn, 1, 2, 3, 1, 2. This 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So just shifting pawn by pawn, and then 1, 2, 3, 1, 2. Right, so we have those pawns. We just connect. As you see, the shape of the graph will stay the same. We just translate it, meaning the shape will not change. We just move the graph to a different place. So inside the parentheses, if we replace x by x minus something, it will go to the right. And if we replace by x plus something, it will move to the left. And of course, that something is a positive number. Right. On the outside though, if we add something, we go up. If we subtract something, we go down. Once again, that something is positive. So be just like that. Now, kind of backward, right? Thinking about this. The x-axis, the right is positive, the left is negative. The y-axis, up is positive, down is negative. So, if we add something, we go up. If we subtract something, we go down. So that works perfectly. Now, the other way around. If we add something, we go to the left. And if we subtract something, we go to the right. So that look backward, right? On the x-axis compared to the y-axis. On the y-axis, positive on the top, negative at the bottom. Perfectly right there. Now, but for the for the x-axis, for y-axis, positive on the top, negative at the bottom. That makes perfect sense. On the x-axis, positive supposed to be on the right and negative supposed to be on the left. But on the x, it works backward. They'll say, why is that? Now, it's very simple. If you consider this function, y equal to x, right? Now, if we minus 2, what we actually do? Now, if it is minus 2 on this side, you want to move to the other side. So the x actually is a plus 2, right? So think about that. So it kind of like that. Bottom line is just keep this in mind. If it is affecting the y-axis, the y values, or anything to do with vertical, it will be the same. It will be like conventional wisdom. If it is anything to do with the x values or horizontal, it will be reverse 2. What reverse 2? What normally the case like minus is on the right hand, plus is on the left. Right. That will be useful when we talk about stretching and shrinking and other forms of transformation. Right. The second part of transformation is vertical and horizontal stretches and shrink or compression. Right. Now, before we do anything, stretch will make something bigger, and shrink will make something smaller. So that's just what it means. Right? Stretch is to make things bigger, and shrink to make things smaller. Right. Let's look at vertical stretches and shrink. When the right side of the function y equal f of x, now if we multiply by a number a, then the graph will be obtained by multiplying each y coordinate by a. So just multiply that by the number. And just for all intention, to make things easier, we just say that suppose a is a positive number. Right. So if we multiply anything to the function, we multiply the function to that values. Well, that makes sense. Now, in terms of stretching and shrinking, go back to what we said earlier. Stretching is to make things bigger, and shrinking is to make things smaller. So, now, if we multiply by the number that is between 0 and 1, like thinking about multiply by 0.5, we will get a smaller number, right? In that case, that will be shrink. If we multiply by something that is bigger than 1, like multiply by 2, it will be twice as big. Again, we talk about positive numbers. If it is multiplied by 2, we make things bigger, therefore it's stretch. Right. So we just multiply the y values by that number. If we make things bigger, that is stretch. If we make things smaller, that is shrink. Right. So look at this example. Consider the graph of f of x equal to 1/2 x. So first of all, the basic graph is y equal to x squared, a parabola. So we graph the parabola. And then what we have is we multiply the 1/2 into it. Now, if we multiply 1/2 into it, all the y values multiply by 2. I mean by 1/2, I mean y values multiply by 1/2. Now, if we multiply anything by 1/2, we will get a smaller number, right? Meaning that it will shrink vertically, because we multiply to the y values. Right. So think about this. If we have the point 2 and 4, the y values multiply by 1/2. So this point will go down to 2 and 2. And the 0, 0 times 1/2 still 0, 0. So negative 2 and 4, the y values multiply by 1/2. That gives us negative 2 and 2. And therefore we have the graph. That is that function. Right. Simple enough, right? Now, next, sketch f of x equal to absolute value of x. So we start with absolute value of x, which is a v. So that is absolute value of x. Now what we do is we multiply 2 into it. So all the y values multiplied by 2. Now if we have a number multiplied by 2, certainly that will get bigger, right? If we have a bigger number, that means this is going to be stretched because we make things bigger. Stretch vertically. Of course, by 2. So, let's see. We have the point 0 and 0. Y values multiplied by 2, still 0, 0. Now if we have the point, say 1 and 1, the y values will multiply by 2, so will be 1 and 2. Now we don't have to do that. So let's say we have this much. That will be the y values, right? The vertical distance. It's going to be twice as long. So we move there. And so on, yeah. So whatever we have the y values, just going to twice as long. So we will have the graph of absolute values of, 2 times absolute value of x. So on this one we stretch it vertically, and this one we shrink it. Yeah, we shrink it vertically. Right. So that is where we have a number in front of the function. Now next we have a number that is in front of x, and what should we do? Right. Originally we have y equal f of x. Now we have a number in front of x. In that case, we just multiply x squared by 1 over b, or we can just say we divide x coordinates by b. Right, so we did say that, remember about reverse manners here. If it works out on the y or vertical, it will work in the same manners, the conventional manners. But if it affecting the x-axis, affecting the x values, affecting the graph horizontally, it will work in a reverse manner. Once again, if affecting the y values or vertical, it will be conventional manners. But if it affecting the x values or affect the graph horizontally, it will work in a reverse manner. Right. Now, in this case, if we have the bigger number, if once again that number is positive, if b is bigger than 1, meaning that we divide by something bigger than 1. Think about like divide by 2. If you have a number divide by 2, we make things bigger, right? Or smaller. Right, think about this. If we have a number divide by 2, that will be smaller, right? Therefore it shrink. And if we have a number between 0 and 1, like 0.5, divide by 0.5 is the same thing as multiply by 2, and that will stretch because we make it bigger. Right, next, let's look at the graph. F of x equal to absolute value of 3x. So this is absolute value of 3x. That's not what we start with, right? Never mind. We start with the graph of f of x. Okay, sorry about that. So we have absolute value of x. Now what we do is we have the 3 here. That is multiplied to x. Now 3 multiplied to x. We have to work in the reverse manner. Instead of multiply by 3, we have to divide by 3. So x values are divided. If we divide by 3, we get a smaller number, right? And getting a smaller number meaning shrink. And this affecting the x values, that means horizontally. So let's say if we have the point 0 and 0, it will stay there because we take 0 and the x values divided by 3, still 0. Now let's choose if x values is 3 and 3, this point 3 and 3. We take the x values 3 divided by 3. 3 divided by 3 is 1. So we have the point 1 and 3. And then so on. It doesn't matter though. Whenever we have the distance, we will cut that distance, or the horizontal distance is x values. We only take 1/3 of it. So this is only 1/3 of it. And so we have the graph. So this is the graph y equal to absolute values of 3x. Right. So this one, indeed, we shrink it horizontally. So we push from side horizontally. So we have that graph. Right, next, let's sketch this. Of course, we first, the basic graph is the square. So we're going to graph a square first. Now we have 1/2 multiplied to it. 1/2 multiplied to x. We work in the reverse manner. Take the x values divided by that. Now, divide by 1/2 is the same as multiply by the reciprocal, which is 2, right? Meaning that multiplied by 2. If it multiplied by 2, we get bigger. That means it stretch horizontally. Right. So first the point 0, 0. If we take the x values multiplied by 2, it's still 0. How about the point 1, 1? The point 1 and 1, the x value is 1 multiplied by 2. So we go here. If we have the point 2 and 4, the x value is 2 multiplied by 2, it's going to be 4. And we don't even need to know the point. Whatever the horizontal distance is, we're going to double it. So we have the graph. Okay. And the graph is still an even function, so still symmetric on the y-axis. Right, this is y equal to 1/2 x squared. Right, I just want to show some feature of the graph. Let's say x squared and then 1/2 or 0.5 x squared. Right, if we graph like this, we don't know which one which, but we can always, let's say, we can change the pattern this to a solid line, very dark, double line, and this we can just say a dotted line. Yeah, so we know which one which. Next, vertical and horizontal reflection. So now, instead of y equal f of x, what we have here, is a negative in front of it. In that case, if there's a negative in front of the function, it will be reflect about the x-axis, meaning that it reflects vertically, or we have the vertical reflection. So once again, if it is on the outside, it will affect in the y values. Now this is inside. It will reflect about the y-axis, meaning horizontal reflection. Right. So let's write the note here because that's rather important. So if we have a number that is outside of original function, outside the parentheses, outside of the basic part of the function, it will affect the graph vertically. Yeah, if we have f of x and then we throw the negative in front of it, it is outside of the function. That means it affect the graph vertically. If it is inside, like this, it will affect the graph horizontally. But in reverse manners. Right? So think about this. If we just have x squared, for example, if we multiply the number into it, in front of it, it will affect the graph vertically. Multiply by 3. Just multiply by 3. Now if we have absolute of x, and instead we multiply by the number into x, so this is inside of the function, inside of the absolute values. Right? If we have inside the absolute values, inside of the parentheses, it will affect in the x values, affect the graph horizontally. So in this case, all the x values is divided by 2, not multiplied, because that is in the reverse manner. So if it on the outside, we multiply the y values by it. If it is inside, we divide by that number. So work in the reverse manner if it is inside. In terms of reflection, it will be the same because we just flip it. So there's no thing as the reverse manner. So once again, if we have a negative on the outside, it will flip the graph. Okay, not really see the function, right? Y equal to negative square root of x. So we flip all the y values multiplied by -1. Therefore, we just upside down pretty much. Now, if we have the negative inside of the parentheses, it will affect the graph horizontally in the reverse manner. But in terms of reflection, you say all the x values divided by -1 or multiplied by -1 is still the same, right? So when the x value is multiplied by -1, so it will be right sign, left becomes the point to the right becomes left, because x value changed the sign. So we have horizontal reflection. If it is negative, to go with the x. Now put all of that together, we have this combination of all the transformation. And just like the order of operation, we do inside the parentheses first and then outside, right? So first inside and then outside. And within the inside, we do the multiply divide first and then add or subtract. Just like order operation, right? So first, it's going to be inside of the bracket. So inside of the bracket. Inside the bracket is affecting the graph horizontally in reverse manner. And after that, we do the outside of the bracket. Outside will affect the graph vertically. Now within that, multiply, divide, and then add or subtract. Multiply or divide, meaning that will be stretch, shrink, or reflect. And then the add or subtract, meaning it will shift. So stretch, shrink, reflect before we do the shift. Whether it's vertical or horizontal, it doesn't matter. Right. Now let's use transformation to sketch the following graph. Right. First, that the basic function is a square, right? So I'm going to draw x squared. Now, we have a few numbers that added to it, right? So, I'm just go back and check what color code that I use. So first we have the -2 here. That of course will go 2 units to the, it's inside, right? Affect the graph horizontally, yes, in reverse manner. So the x-axis usually positive on the right, negative on the left, but this one in the reverse manner, so it is on the right. 2 units. The +1 here be 1 unit up. So up 1 unit. Now we have the 1/2 multiply in front of it. So this is multiply in front of outside the parentheses. So therefore, y values, it affects the graph vertically because it's on the outside. So y values multiplied by 2. Multiplied by 1/2. Meaning that will shrink. Vertically. By a factor of 2. Right, so, so multiply y by 1/2, so multiply string vertically by a factor of 1/2. Now, the next order operation, which one do we do first? Well, inside then outside, right? So first, we'll do 2 units to the right, so this is the first step because that is inside. And then it's outside. On the outside, we have multiply, and then we have add. Of course, we multiply first, and then we add. So that is the order of operation. So if x squared here, first thing, move 2 units to the right. So that point 1, 2, 1, 2, 1, 2, So that is 2 units to the right. So I just say this is the first step of operation. So that is number 1. Next, shrink vertically or multiply the y values by 1/2. So whatever the y values is, I'm cut in half. So here's the 1, y value equal to 1 cut in half. So that is where we shrink it vertically. And that is the second part of the graph. Second graph. And after that, we will move 1 unit up. So this is easy. That point 1 unit up. That point 1 unit up. That point 1 unit up. Yeah, that point 1 unit up. Yeah, just check the color code here. So yeah, so that's what we have. So the final graph is that. Yeah, it's kind of grounded and only a sketch, but the most important, of course, not the graph itself, but how do we do the transformation? What is the sequence of transformation? Right. The next one is a little bit more interesting. We have negative x as right, but this one we should factor out the negative. Then we have x minus 2. Remember, the coefficient, whatever it is, has to be in front of x. There will be just a parenthesis. There's nothing in front of it, right? So, of course, we have the square root. Square root of x. And then what we have here is multiplied by negative. If we throw the negative in front of x, it will flip the graph horizontally. So that is reflect horizontally. Horizontal reflection, or just flipped. And then here we have the minus 2. Because that attached to x, we will affect the graph horizontally. So it will be to the right 2 units. And then next, which one do we do first? Right. So inside and then outside. In this case, we're talking about the square root. So inside the square root, outside the square root. We have nothing outside the square root. So there's no, the graph only, there's no effect, no vertical effect to the graph. What we do is just inside, meaning the transformation only affect the graph horizontally. So we have reflection and then 2 units to the right. So which one do we do first? Well, it is both of them inside, but we have to multiply by negative 1 and then minus 2. Think about that. Of course, we're not trying to do inside the parentheses. We talk about inside the square root, under the square root. So let's multiply first, and then add or subtract. So we'll do the reflection, and then we move 2 units to the right. So that is the order of operation. So first 2 units, reflect, so flip it upside down. So that is the first step. And then move 2 units to the right. So that point 1, 2. And then this point 1, 2. This 1, 2. So that is the final graph. Of course, if we want to graph it, first we have square root of x, and then we have square root of this time minus x plus 2. Just make this a double line, so that's the square root of x. Yeah, see, that's why we need to check, right? So this is horizontal reflection, right? Yeah, so that's why we need to check. Yeah, but I said that the concept is perfect. It's just the execution is off. And then move 2 units to the right. So 1, 2. And then 1, 2. So it will be this graph. So I said I did this perfectly. I just execution is way off, right? Said. Yeah, it's nice to check the answer. Yeah, just check this one too. So yeah, we just need to enter one function. Yeah, look right. Yeah, so be careful with that. Right. Next, we have absolute values. This is the basic function. So we have first absolute values. Right, now we have a few things attached to it. First, I'm not saying that we do that first. Just say we have the plus 3 here. That would be 3 units left. The minus 2 will be down 2 units. And there's the minus, which would be vertical reflection. Because it's on the outside of absolute values, reflect vertically. and then there's a 2 as well. So y values multiplied by 2. Multiplied by 2, meaning that will be stretched. Now next, what do we do the other operation? So once again, inside and outside. So inside we have left by 3 units, so this is first thing we do. Is move everything to the left 3 units. And then on the outside we have minus 2, multiply to it and then subtract 2. So multiply and then add or subtract. So reflect or stretch, we do that at the second step. And then finally down 2 units, that is the third step. Right, so be careful on this one. Move 3 units to the left. So that 3 units to the left. So that's the first part of the transformation. Next, we reflect it vertically and then stretch. So we do that look like 2a and 2b. It doesn't matter. We do that at the same order. So we can multiply by 2 first and then we flip or flip multiply by 2. Those two are interchangeable. Because multiply by -1 and then multiply by 2, or multiply by 2 and then multiply by -1. It doesn't matter. Still just multiply. Right, so I will do the stretch first and then flip. Right, so 0, 0 will stay the same. The y values, let's say this is this much, it's going to be twice as long. And y values here, it's going to be double. So that is the second step. It's a V. So we stretch it vertically, right? So just pull it vertically. And then flip it vertically. So that point up becomes down, up becomes down. That is second step. And then move everything down 2 units. That 1, 2, 1, 2, 1, 2. Right, let's just graph. -2 absolute values, x plus 3 minus 2. Yeah, so I have that. Yeah, it doesn't look like this V, but because the scale is off. So if we want to change it, hit that square, in that case you will see that is more like the graph here. So in this case, it's 1 unit, and up or down will have the same length. So yeah, that's what we have. Next we have 1/2 x cubed minus 2. So the x cubed, we haven't done it yet. So 1 cube is 1, -1 cube is -1, 2 cube is 8, -2 cube is -8. So this will look like that. is the x cubed. Next we have 1/2. Now 1/2 multiplied to it, it is inside the cube. So inside the cube, the x values will be multiplied by, because inside it must be in the reverse manner. So instead of multiply by, it will be divide by. Divide by 1/2 is the same thing as multiply by 2. Multiply by 2 meaning it will stretch. And of course the x value, so it stretch horizontally. Right, so it stretch horizontally. And then the minus 2 here. So be 2 unit down, 2 unit down. Alright, so first on the x values, divide by 1/2 or multiply by 2. So if the x value is 1, it becomes 2. If it is 2, it becomes 4. Yeah. So we stretch it horizontally. Right. And then move 2 units down, so this box is easy. So 1, 2, 1, 2, 1, 2. So that's what we have. Now let's just graph. Yeah, let's graph the x cubed too. And then 0.5 x cubed. Of course, that starts faster than x cubed. Alright, let's change the pattern. Make this a double line and make that a dotted line. Right, x cubed and then 1/2 x cubed minus 2. So that's what we have. Now, more transformation. This one we have to do it by hand because we don't have the basic graph. The basic graph is given. So, the graph is given like that. So what we have here is multiplied by 2. So that means y values multiplied by 2. Minus 1, so it will be 1 unit to the right, and then plus 1 will be 1 unit up. Order operation: inside first and then outside. On the outside, multiply first and then add or subtract. So 1 unit to the right. So this one 1. Simple enough, right? Just move everything 1 unit to the right. Next, y values multiplied by 2. So whatever the y value is, multiply by 2. So if it is 0, 0 multiplied by 2, still 0. So that point will stay here for sure because the y value is still there. Our y value here is 1 multiplied by 2. Y value here is 1 multiplied by 2. Here, y value is negative 2 multiplied by 2, it becomes negative 4. And then this point negative 2, so that's what we have. So this is the second. So 1 unit to the right, and then stretch by 2, and at the end move 1 unit up, so that's easy. One unit up. One unit up. So that's what we have. Right. So 1 unit to the right, stretch it by 2, and then 1 unit up. So those are the order of transformation. Right, next. We have plus 2 here. That means 2 units to the left. There's the minus. Multiply to it. That will be reflect vertically. And then at the end, minus 2 be 2 units down. So we're going to write that out first. And then we determine the order of operation later, the order of transformation. Right. So inside then outside. Inside we have the 2 units left. So that's the first thing we do. And then on the outside we have the minus, multiply to it, and then the minus 2. Of course, minus is the reflection. We do that second. And finally, 2 units down. Right, so first 2 units to the left. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So that is the first step. Move everything 2 units to the left. Next, reflect it vertically. So up becomes down, down becomes up. So if this one we go 2 units down, it becomes 2 units up. This point 4 up becomes 4 down. This point 1 up, 1 down. 3 up, 3 down. And then 0 times 0, 0 times 2 is still 0. I mean 0 times negative is still 0. So we're going to have sorry, I should work with the points. Sorry, not that. I told you I've always, in math, prefer to use pencil, but it will be difficult to see if I use pencil. Yeah, so sorry about that. Anyway, yeah. So this point up becomes down, and up 3, down 3, 0, still 0. that is the second graph. You could see that there's the mirror image of the graph here and the graph there. Now we just have this one move 2 units down. 1 2 1 2 1 2 1 2 and 1 2. Yeah, we move that 2 units down. That is the graph number 3. Right. I said the most important is to be able to determine the transformation and the order of those transformations. The graph, of course, the calculator can graph it, unless of course we don't have the function to enter in the calculator, in which case we have to do it by hand. So let's check one more time. 2 units to the left, flip it upside down, and then 2 units down. So that's what we have. This one, 1 unit to the right, and then y values multiplied by 2. So we stretch it vertically and then move 1 unit up. So you see, when we put the numbers in, we can determine what order of those transformations that we did. So we don't write the numbers, kind of difficult to know what is the final graph. Right, that's what we have. All right, next. Let's see, write a function for the following. So we have f of x equal to x squared. Yes, but that is shift 3 units to the left and then stretch vertically by 2. So in general, we have f of x is equal to something square. That's all we know, right? Now, if it moves 3 units to the left, that means left meaning horizontal, so it's going to be inside the parentheses here. Left meaning that's going to be plus 3. Yeah. And then stretch vertically by 2. Vertically, so it's going to be on the outside. Stretch, so make it bigger, multiply by 2. So if we want to check x squared 2 times x plus 3 square so I have x squared, yeah, move 3 units to the left and then stretch by 2. That's what we have. So that's good. Next, we have f(x) equal to square root of x. This one is reflect horizontally. So reflected horizontally. So we have to throw in a negative. And then shift 2 units up, plus 2. So the graph is actually that. Right, square root of x negative square of x plus 2. Yeah, let's make it a double line. Right, we have square root and then horizontal flipped and then 2 units up. So that's what we have here. Oh, that's good. Now let's see, we'll do in reverse. If we have the graph, how do we write the function? Okay. Now first of all, this looks like parabola. So this is an x squared. So that's what we know. Right, what else do we have? Original x squared, we have the vertex at 0, 0, right? But this time, let's see the vertex 1, 2 to the left, and then 3 up. So we have 2 units, actually this to the right, and then 3 units up. So 2 units to the right, and then 3 units up. But then we have to flip it upside down too. So what they call flipped. It's not correct though. Start with x squared, and then we have negative x minus 2 square plus 3. Yeah, let's change that to a double line. Right, x squared. Yeah, so that looks right. And then next, this looks like the graph of the square root. So once again, we start with square root. And in this case, we only have translation. So 2 units to the left. And then 3 units down. Unit down. Square root of x, square root of x plus 2 minus 3. So that is square root of x, and then as you see, 3 units, 2 units to the left, and then 3 units down. So that's what we have, the function. So of course we need to know the effect of each part to the graph. If it is inside, it will affect the graph horizontally. If it is outside, it will affect the graph vertically. If it is inside, it will affect the graph in the reverse manner. Like multiply becomes divide. And then within the inside or on the outside, stretch, string, and reflect, meaning we do the multiply, divide first, and then add or subtract. Right. So of course we have to know the transformation to the graph, or we look at the graph, we know the transformation as well. Right. And with that, I stop this section here. Thank you for watching, and see you in another video in pre-calculus.